Lesson 4.4, Parallel and Perpendicular Lines. Our essential question is, how does the slope help you determine whether lines are parallel, perpendicular, or neither? For our two new vocab words, we have parallel lines and perpendicular lines. These are terms that you've probably worked with in the past. So as a reminder, parallel lines have the same slope. So that means that their steepness is exactly the same. They don't have to be horizontal or vertical. They might be diagonal or oblique. But they've got the exact same slope, the exact same steepness. So it says parallel slopes stay the same. Perpendicular slopes flip and change. The next slide should explain that a little bit better. Perpendicular slopes, when lines are perpendicular, they form 90-degree angles. They don't have to be horizontal and vertical. They could be oblique or diagonal lines. So there's two examples right there. So parallel slopes stay the same. Perpendicular slopes flip and change. That's going to be really important for you to remember throughout this chapter and the rest of the year. Okay, so the next thing that we have is just a table, because we need to make sure that you understand that if you can find the slope of the original line, parallel slopes stay exactly the same. So that means that this column, the slope of your new line, is going to be exactly the same. If two lines are parallel, their slopes are the same. Remember, sometimes you need to reduce your slopes to lower terms to see that they're the same. Those two columns, though, are exactly the same, the original slope and the parallel slope. Now, the perpendicular slope. Perpendicular slopes flip and change. So what that means is, if I take the 5 of my original slope and make it a fraction, I am going to have to flip the fraction over. So instead of 5 over 1, it's 1/5, and change the sign. So it started positive, now it's negative. So these are like opposite reciprocals. Opposite reciprocals. Their product, if you multiply together these two slopes, your product is always -1. -1. The next one starts out -3, so I put a 1 under it, I flip it over, and I change the sign. So now this one is positive. 1/2, I flip to 2 over 1, I change the sign to a negative. That one reduces, so -2. The next one I flip and change, I would get 3/2. What happens when you take 1 over 1 and you flip it and change it? Flipping 1 over 1 gives you the same exact fraction, 1 over 1. Then when you change the sign, it's simply -1. The next one, pretty straightforward, -7 over 4. And the last one, if I put a 1 under it, it's going to be a positive 1/8. So, flip and change. There are two things happening with perpendicular slopes. Flip the fraction, so that's the reciprocal, and then change the sign. Okay, now this next slide says determine whether the lines are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. Well, if I look at the slope of this first line, because it's written in slope-intercept form, my slope is -3, or -3 over 1. If I look at the slope of the second line, my slope is 1/3. They are opposite signs and reciprocals. So I believe my lines are perpendicular based on the slopes. If I wanted to graph them, I could graph them just to check and make sure that they look like they're perpendicular. My first line starts at +1 and it goes down 3 over 1. I could reverse that. So here's my first line. My second line starts at -2 and it goes up 1 over 3. I can reverse that. you can see from my graph that it does look like they intersect at 90-degree angles. So it makes sense to me that those lines are perpendicular. My next example, the first one, is not written in slope-intercept form right now, so I'm going to have to do a little rearranging first. So, remember we need to get the y by itself, so I'm going to subtract the 3x on both sides. We worked on problems like this in chapter 2, literal equations, and then again in lesson 4.1. So subtracting the 3x leaves me with 4y equals, and it's really important that I put these in slope-intercept order. So my negative 3x needs to be before my positive 12. Then I divide everything by 4, and I simplify. My slope is a beautiful fraction, so I'm leaving that alone.
Ms. Burke-Williams, please call extension
My
6801. Ms.
intercept,
Burke-Williams,
12 divided by
6801.
4 is 3. Now I can compare my slopes. I have a slope of negative 3/4, and I have a slope over here of positive 2. So I do not believe that these are going to be parallel or perpendicular. So I'm going to write neither, and then I'm going to graph them just to make sure that that looks accurate to me. So start at positive 3, go down 3 over 4, or reverse that. Draw my line. Then my second one starts out at negative 1, and it goes up 2 over 1. Like that. So if I would have graphed this one, I may have thought they looked like they were perpendicular, but looking at the slopes, they did not flip and change, because the second slope is 2 over 1. The first one would have had to be negative 1/2. So I am correct in saying that they are neither. But as you can see, if you graphed it and just went off of the graph, you may have gotten this one wrong. So it's really important to know those details about your slopes. Okay, one more. This one looks like I need to rewrite both of them a little bit. So the first one, I subtract my 4x. So 6y equals negative 4x plus 18. Divide everything by my 6 and reduce. Negative 4 over 6 reduces to negative 2/3, and 18 divided by 6 is 3. Now my second one is only one step to get the y by itself. I just need to divide by the 3. So my slope again is negative 2/3, and my intercept now is 2.
Will the custodian please call extension 6801? A custodian please call extension 6801.
Both of my slopes are negative 2/3. So that will result in parallel lines. And on the graph, the first of my parallel lines has an intercept of 3. The slope is negative 2/3, so down 2 over 3. And then the second one of my parallel lines starts at positive 2, so it's just below. My slope is still negative 2 over 3, so it's just below the original line. So those are clearly parallel. This is a click and drag, so it's just a practice looking at a system of 2 equations. The two that have the same slopes are these two. The one that is parallel is the one, or sorry, those two are parallel. The one that's perpendicular is the one in green, because that's the only one where they flipped and changed the slopes. Flipped and changed. So look at these two that are neither. Negative 1/5 would have to change, or positive 1/5 would have to change to negative 5 over 1, and negative 2 would have to change to positive 1/2. So that's why both of those systems of equations are neither parallel nor perpendicular. So the slopes have to flip and change. Two things are happening. You can write your summary now. And then here are your homework problems.